Okay, in this chapter, we have covered how Egyptian people figure out to write the number between 0 and 1. Usually it's kind of fraction form in our number system, but they didn't have such a thing, but instead they want to assign some symbol to unit fractions, and they figure out to convert any kind of number between 0 and 1 into the sum of those unit fractions. I said any number between 0 and 1, but technically it should be just rational numbers, right? But okay, we're going to talk about that one later. But anyway, but the process was only the doubling method or make a halving method, right? So it took really long time, and eventually they actually make kind of reference table and just try to see it. Okay. But people were kind of interesting about their method and looking for a better way or faster way to get those sum of unit fractions, right? So around 13th centuries, the Fibonacci actually make his own algorithm to express any rational number between 0 and 1 as the sum of the distinct unit fractions. Okay? And that one was more developed nicely around late 19th century by Sylvester, and they call it is the Fibonacci's method. And the method is like this. Let's just choose any number, okay? And of course we are most likely thinking about just between 0 and 1. Eventually, if you take the division, we want to take care of just the remainder only, right? So let's say, for example, it's 3/4. Then the notation here, we need to do that. It's like this. So we call this a ceiling. Okay, that's the most popular name. So it's a ceiling of x, which means we are looking for the lowest integer, which is greater than or equal to x. So that's the meaning of ceiling, right? So it must be greater than or at least equal to that given number. And among those, because there are infinite many of them, we just to take the smallest of them. Okay? So for example, if we have 7/3 of the ceiling of it, so it's going to be about 2 point something, right? Okay. Then it should be 3. Any integer greater than equal to that number, and among those we are taking the smallest of it, right? So be careful about whether it's when it's negative numbers, but we're not dealing with it. So let's just look at the Fibonacci method. The method is like this. Let's just choose any fraction between 0 and 1, any rational number between 0 and 1, then it can be written by a over b. Then let's take the reciprocal of it. So be careful. A over b is between 0 and 1. So if you take reciprocal of it, it must be greater than 1. It's guaranteed, right? And let's take the ceiling of it. And let's say that is integer. Of course, let's say that is n. Then we can write down that a over b, which is between 0 and 1, as the sum of 1 over n plus certain number a1 over b1. And we're going to handle how to calculate it, but let's assume that way. Now, if a1 itself is 1, then this form is sum of 2 unit fractions. So that's it, right? That should be the answer. But if it's a1 is not 1, then we just do the same, we just repeat the same procedure for a1 over b1 again. So take the reciprocal of that result, and let's say the next one is m, whatever. Then this number can be a over b, it can be written to 1 over n plus 1 over m plus a2 over b2. And if it's 1, then that's the nice decomposition of a over b by the sum of 3 unit fractions. If it's not, then we just repeat with that fraction again. And as mentioned in here, the numerator is going to be getting smaller and smaller. So eventually it will end at certain moment, right? And it becomes 1. Therefore, we'll get the sum of unit fractions for any given number. Okay, so let's just use the following example and how this procedure is working. So first of all, we want to write down 10 over 23rd by the sum of unit fractions. Of course, all distinct in this case. So first thing we have to check is, yes, that fraction is between 0 and 1. Then let's take reciprocal of it, which means kind of convert numerator denominator each other. So 23rd over 10. If you need, you have to calculate it, but it's about 2.3 something like that. And we are looking for the ceiling of that number, which is 3 right now. So that 3 is n, right, in our explanation. Okay? So the next procedure is, we found that much. The next procedure is, how can you change that a over b, which is 10 over 23 equals 1 over n plus another fraction. How can you find those a1 and b1? It actually is easy, because we want to write down 10 over 23 equals 1 over n plus whatever, right? So that number, let me just put kind of square rectangular. Okay? We are looking for that. So because of this, the form that we are looking for is actually 10 over 23 minus 1/3. So from here, let's make common denominator. So by cross multiplication, 10 times 3 minus 1 times 23 over 23 times 3, right? So it's 30 minus 23 over 69. So that is 7 over 69. That's our A1 and B1, right? And A1 is not 1, so we have to repeat the same procedure for that number. But now, the numerator of the given fraction was 10. Now, this new fraction form has 7 for its denominator. It's decreasing, right? It's getting smaller. So this procedure will be n at certain moment. So next step is, of course, you don't need to check this one. It's definitely less than or between 0 and 1, right? So let's take the reciprocal of it and take the ceiling of that. So if the numerator is 70, then that value must be 10, but it's 69 is 1 less than 70, which means when you take the division, it's going to be 9 point something, right? We don't want any accurate calculation here, because we want rough kind of approximation, like integer value to that fraction. So 9 point something, and ceiling of that should be 10. So that's our m at this moment, right? Then how to get that a to b2? Okay, you just think like this. It should be from that original fraction. Right now, forget the previous ones. We are just dealing with this much, this here, right? So the original fraction is 769, and we need to subtract, be careful, reciprocal of it, right? 1 over m, right? Like that. So that is 7 times 10 minus 1 times 69 over 69 times 10. So it's 70 minus 1 is 70 minus 69 is 1, right? Of course, 19. So it's going to be 1 over 690. That's our A2, A3, but A2 is 1 right now, right? Which means we can stop here. Okay? Then all together, from this format, the given fraction 10 over 23 is written by 1/3 plus the first box, right? First rectangle. And that first rectangle can be written by this way, right? 769, but instead of 769, it can be written by that 1/10, right? And with this number. Can you see that? Okay, so forget the previous steps. Forget the previous steps. Just imagine this is what we have. Then from this one, our assumption was here is 769 should be 1 over 10 minus the box, right? And therefore that box is 760 minus 1/10, right? Which means 769 is actually 1/10 plus the box, right? So it's going to be 1/10 plus the box, but box is 1 over 690. So altogether, the given number 10 over 23 can be decomposed to the 3 unit fractions like that. Okay, so let's just do in general case, right? So please practice with this one, but now it could be general forms of entire one, right? Okay, let's decompose this fraction into a sum of distinct unit fractions. Now, at this time, the numerator is greater than denominator, so we're expecting some integer values. So the first procedure should follow the Egyptian method, right? So it's kind of combination of Egyptian method and Fibonacci method instead of the Egyptian method altogether, right? Because Fibonacci method is simpler and faster, right? But please remember both, right? So you have to kind of calculate either way. Okay? Doesn't matter. So let's do this way. First, do you remember how to get the division? We have to write down the divisor, which is matching with 1. And we want to get the result 100, right? So eventually we need to matching with this one. So make it double. Then it's 38. Make it 4. And it's 76. Then we know if we make it double again, then this number is greater than 100. So we can stop there, right? And try to adding up those second column values. But adding these two largest ones, it's 114, right? It's greater than 100. So which means we don't want to include that, right? So just adding up these two, then it's 80 and 95, right? So we are looking for to get 100, right? But we only get up to 95. So when you're adding those two columns, the 5 is matching with 95, right? Which means when you take the division of that, we are going to get integer value 5, right? And still have some left over, which is we need to subtract, right? 100 minus 95, or this 95 is 5 at this moment. So 5 over 90. Okay, so be careful. We got the same 5 and 5, but remember which one got which, right? So we have to calculate for certain things to decompose that fraction forms for the remainder part. And if you want to use the Egyptian method, then we have to take the half of it, right? So half, and half of that is 2, which is 9 plus 1 half, right? And take the half of it, 1/4 and 2 nines plus 1/4. You know how to do that, right? But instead of those methods, let's just calculate these 5/19 by using Fibonacci method. Okay, so remember we have this 5, but let's just look at that 5/19. Okay? How to do this. And the first thing we have to do is take the reciprocal and get the ceiling of it. So 19/5 means not 4, right? 3 point something. So actually the ceiling value must be 4. Then we have to subtract that from the original fraction, right? Not 19/5, be careful. 5/19 minus 4 is, okay, let me multiply, 5/19 is there, but I want to multiply 19 for 4 to get the same denominator. Oh, no, sorry. It's the other way, right? Because we get negative, of course. So it's going to be, because we are looking for box, right? So 5/19 minus 1/4, 1/n, right? That's our box, okay? Or A over B form. So that is 5 times 4 minus 1 times 19 and 19 times 4. So altogether 20 minus 19 is 1, okay? We are lucky. At this moment it's 76, right? Therefore, we have that 5/19 is, do you remember? 5/19 is 1/4 plus box, which is 176. Okay, so that's we got. So all together, that 119 is 5 plus that fraction, which is this one. So it's 1/4 plus 176. Okay, as a practice of what you have covered in this video, how about multiplication of those numbers? So please remember, the notation is done by our method, right? Our numeric values, but that notation should be in Egyptian symbols, right? Some 2 for 2 kind of line segment, right? And quarter, there is kind of matching symbol for that. So they just put those symbols and multiply by another one. So it's almost like no way to calculate it, right? In this case. But there is a method to handle that. Okay? So this is kind of nice practice what you have covered so far in this chapter entirely. Okay? So let's look at here. Before doing anything, it's like this. It's a simple example, but like when you multiply a plus b with something, right? Then that is same as a times a plus b times a, right? So we want to use that method, which means we need to multiply 2 plus 1/4 with that notation. Of course, then we are looking for simpler one, which simpler one means less number of terms, right? Then we want to multiply 2 with entire form and 1/4 with entire form. Okay? So just write down that entire form, 1 plus 1/2 plus 1/7. And matching with 1 and to get 2, right? So make it double, and we are going to talking about that portion a little later. But next one is 1/4 multiplied by that. So to get it 1/4, we need 1/2, so 1/2 and 1/4, 1/4, make it half and half. So as you can see here, this one is actually result of 1/4 times 1 plus 1/2 plus 1/7, right? It's in our method, it's clear enough, right? But once again, they need to follow these procedures, right, to get that result. Okay? But anyway, so second part, the multiply by 1/4 is easy to get it, but let's look at that procedure. So let me just write down one more time. When you make it double, then it's 2, 1, and 2 sevens. Okay. The next method is, this is not the sum of, okay, that is same as 3 plus 2 sevens. Integer is okay, but that is not unit fraction. So these 2 sevens must be converted to sum of unit fractions. We have covered many different methods so far, right? So even we have some reference table, right? Method. So 2, if the fraction has 2 and denominator is 3k or n, there are several different methods here, right? But once again, let's just practice the Fibonacci method. So let's think 2 7 separately. Okay? Then to get that form, we have to take the reciprocal of it and take the ceiling of that. So it's going to be 3.5, right? So it must be 4. Then the box is the original given fraction minus 1 over n, right? So it's going to be 2 times 4 is 8, minus 1 times 7 is 7, 4 times 7 is 28, so it's going to be 1/28. Okay? So let me rewrite again, it's 2 sevens must be same as 1/4 plus that box, and box is same as 1/28. Okay, so this is nice decompose of that. So this product 2 times that one is 3 plus, instead of 2 sevens, we can put 1/4 and 1/28. Okay, so all we need is adding up those two results, which is, that is kind of A times capital A part, and that is B times capital A part, right? So just adding those two together, which is, let me use our own method, own style. So we are looking for that result, which is sum of 3 plus 1/4 plus 1/28 plus 1/4, 1/8, and 1 over 28, right? So altogether 3, 1/2, 1/8, and 1/14. And please use other method, right? And practice for that, and to find out you get the same result for that.